So now we're going to have a look at how we actually implemented the quarterly demo that we've just seen, right, with the nice picture, and what are the challenges that we found to implement this. And this is for our multi-tenant Docker Swarm, no, Kubernetes cluster. And we remember that this is the platform that we are running, and basically the product that we're designing and talking about is the product named Ship, which is this Kubernetes cluster in the middle. If it works, yes. So this is the Kubernetes cluster in the middle, and what we need to integrate it with all those tools. We receive things from Spinnaker, FIAS, and we integrate it with metrics, logs, how we do this, and we have some numbers about it. So this cluster, we need to serve 60 tenants. We may come back to what is a tenant afterwards. We have actually 2 clusters currently running in production. We have 2 regions, one in Europe and one in the US. We are running over 3,000 pods, like actual workload. This is excluding the system pods. This cluster is running 130 nodes. Well, obviously, as we've seen, not everything is fully packed. We have some room for optimization. And we saw the metric going up early on, but the traffic inside those clusters have doubled over the past month. So we are having a very huge increase of usage. And so the current architecture that we are having looks like that. So we have one single or 2 regions, but we're going to focus in one region in this case. One single cluster. It has, considering 2 tenants, we see that we have 30 times more. And this cluster, obviously, the cluster is stateless, and it needs to talk with a bunch of services for both tenants. In this case, this is in the example, it is Kufar and Subito, which are 2 of the marketplaces that we run. And everyone has a database, eventually some DynamoDB, needs to talk to some of their own EC2 instances from the previous installation. And what do we do to isolate those tenants so that basically one guy from Kufar cannot actually reach the instances and the databases from Subito? The first thing that we need to do is to isolate the API. So we're providing the tenants a namespace, and the tenant is restricted to this namespace. They cannot go away from this namespace. They cannot deploy application in another namespace, like Kufar cannot deploy something in the Subito namespace. This is not permitted. How do we do this? We do this with basically our current installation, which is where the teams are actually defined. We have the Active Directory, because some of the marketplaces are actually having an Active Directory, most of them. And we have the the G Suite, which allows us to hang on with the central teams that we are part of. So we have two sources of truth for groups. This defines the groups. Those are synchronized into Okta, which is our identity provider for the whole company. And, well, then we have this tiny Golang application that is talking with Okta, and that is retrieving the groups. And every time the user is accessing the API server, connecting through our VPN, because we're not obviously exposing the API server and the API over the internet, of course. Every time he is accessing the API server, it goes to this webhook that calls Okta, and that verifies what are the groups they're running. So we know the groups that the user is in, and then we just need to bind the given group, the given administration group, to the namespace administrator. End of the story. And then we have another role. We have the role definition, which defines the namespace admin, which grants privileges for this exact namespace. So there we have isolated the user using the API, and they cannot deploy in another pod. But there we still have when he runs pod, he can actually exec into a pod, and he can still talk with the database underneath, the EC2 instance. So this is a plain network. We have one single cluster, a plain network. How do we actually isolate up to the different instances and networks that we're having? Those are basically, we have to imagine that there is here a different VPC. So this is a different, we have a peering between the two VPCs, and we need to constrain pods in a given namespace to not reach the instances and the databases of another namespace. How we do this? Basically, we use the plain Kubernetes object, the network policy, that says that, okay, we are, so this is, you have the egress there, so the pod in a namespace is only able to talk to a given set of ranges, which are defined by the VPC peering itself. Though we have a plain network in this Kubernetes cluster, and the pod in one tenant can still reach the pods in the other tenant. And this is what we go with another network policy, which works on the ingress, and then we filter here on the namespace. So we have now all these networks pretty isolated, and we cannot cross-reference. So Kufar is constrained to his data, and Subito is constrained to his data. But we have another challenge. This challenge is, how do we make sure that Kufar, for example, is not deploying by mistake or voluntary because we have somebody that is fed up with the company. We hope that this doesn't exist. But deploying something in his namespace that actually references Kufar, or Kufar referencing Subito, or on the other way around. We did it basically by using the open policy agent that we see here, and same kind of schema. Every time the user here is accessing the API server or any other provider, this is the CI/CD pipeline, this is Spinnaker, or even pods inside the namespaces, they are constrained with the same rules. We are checking that the host name that is actually used by a given user is actually matching and only used inside this namespace. So we have this. We can read the nice and friendly OPA policy, but basically this is there. Like another namespace cannot use the same host as the current namespace, right? So we have unicity there. About one host can only be served from one namespace. We solved this problem. Is this enough? Do you think this is enough? Yeah? Well, what can go wrong with this? Anybody has an idea? Well, in this case, basically, a user would deploy this ingress, and what would happen is that after a while, the ingress starts serving 503, like backend, no backend, or don't rely on the new ingresses. What's happening? Basically, there is a snippet, and this snippet has a syntax error. And this makes basically a single user to be able to tear down the whole ingress for the cluster. So we didn't isolate good enough. What we did to solve this problem is that actually we created the pull request on the Nginx ingress controller that we are using, and we proposed to have the webhook, and this webhook is actually doing the same thing as OPA that we were seeing earlier on, which is every time an ingress is coming, I'm going to check that the syntax is valid. And what will happen with the same ingress that we've just seen in there, see, gzip column off, it will say that, well, unknown directive gzip. It's not the best user-friendly interface, but at least I know that there is something wrong with the gzip that I'm creating in my ingress, and I prevented the whole ingress to be turned down and to impact all the users of the cluster. Imagine you have a user doing something for test on a Saturday night because he wants, and he has access, he is admin, maybe he is on call. He do a quick fix in production for a system, and goes to bed, and actually there is a syntax error, and your whole system is actually teared down in the middle of the night. So this is something that we don't want to happen, and that we solved with this webhook. Next, what can go wrong with this? If you deploy this in your cluster, you have to know that yes is a command that is actually written to have an optimized throughput in terms of number of lines that it can write on the STD output. It's a desired state. And basically what Kubernetes is going to do is that it's going to run this command until completion. And they take it as a buffer. So it will take the whole output of the command inside the buffer. But it's optimized for having an actual very, very, very high throughput. So it's going to basically completely fill all the memory. And this is Alan with there that raised the issue in November last year. That basically the node is all the nodes of the cluster is going to be, or the nodes that are running this pod is actually going to be turned down. And because Kubernetes have this self-healing behavior, the actual pod is going to be moved to another node, and this will progressively just tear down your cluster. Do we have a solution? Well, yes. We need to upgrade to 1.17, apparently. So it has taken roughly 1 year for Kubernetes to solve this problem. And if you're running something that is not 1.17, which I think most of us is doing, you are vulnerable to this problem. So maybe you want to be careful about this. Next challenge that we faced is, as Gallo said, maybe you don't want to use this log aggregation things there because maybe it's too expensive for you, or maybe you already have your stack, your logging stack that you're very happy about it. You have a lot of components integrated with it, and you just want to plug the whole platform to benefit the whole platform, all of this, but to use your own stuff, your own stack. And how do you manage to actually provide this as a service and let the user opt in without having you to actually configure your own cluster to run this hook, to route the logs for this specific user, should it be Subito as we said, or Kufar, to his platform. What we did is basically, there is a missing logo there because they don't have any logo, but this is the VMware Fluentd operator that we are using. And what this allows is that the user, just by throwing this tiny config map, a tiny configuration inside the cluster, can say, oh, all the logs that concern my namespace, and only my namespace, and we know that this is isolated, should go to this host. And then Fluentd will be reconfigured dynamically to actually send all the logs to this host, which is what we named the escape hatch. This is a pattern that we are implementing regularly to allow users to benefit most of the platform, but hook in when they want to use their own solution because reasons. We're not there yet with all the challenges. We still have a lot of challenges in front of us. As we've seen, the cluster that we are running is growing. We have 1 cluster per region. And by growing this cluster, we are increasing the risk. What happens if this cluster actually breaks for whatever reason? For example, certificates that expires. Things that can happen, right? So the next challenge that we are going to work on is how we make our distribution, our implementation of Kubernetes, highly available. What happens and how we can do for the cluster, under the set of cluster actually, to keep relying on, to keep being reliable, even if one cluster fails. So this is the very first thing that we are gonna, very next thing that we're gonna have a look at, because this is, as the risk is growing, we need to invest on this. Then, as we said, we have 2 different regions. We operate clusters in 2 different regions, but currently the users need to actually configure their application and do the routing between those 2 regions on their own. This probably is one of the next challenges that we are gonna face, which is how we can actually get this to be completely integrated, completely transparent as a service for the user, to just say, I want to run my application and I want to run in this region and this region, Europe and the US. And the last challenge that we are foreseeing so far, of course there are going to be a lot of other challenges and a lot of other possible talks, is how we actually manage, unlike what we were saying earlier on, okay, just update the Kubernetes version and your cluster is going to be up and running, the master is going to be up and running, but your application will just fail all the way through. Our next challenge afterwards should be about streamlining the version upgrade. How do we get the versions to be upgraded transparently for the user, or with acknowledge for the user, to be able to say, okay, this is safe, your application is now running in the next Kubernetes version, the 150, let's say, and we check it's completely safe. You can just press the button and we will route the traffic to this new version.